So here we're asked to write 9 over 10 as a decimal. So we're starting with a fraction and we're asked to convert it into a decimal form. And when we go with working from a fraction and converting it to a decimal, we're simply going to divide. So 9 over 10, the fraction, is basically saying 9 divided by 10. And if we divide 9 by 10, that's going to give us the answer in a decimal form. So if I'm to write this out here, 9 divided by 10, we're basically making it 10 times smaller, and that's going to give us an answer of 0.9. So the answer to this question is 9 divided by 10, which gives us 0.9 as a decimal. Now in this question, we're asked to write 0.3 as a percentage. So this time we're going from a decimal to a percentage, and to convert from a decimal to a percentage, we're going to multiply by 100 to take this decimal and get it into percentage form. So we have 0.3 multiplied by 100, and that gives us an answer of 30%. So the answer here is going to be 30. So in this question, we're asked to write the number 2538 correct to the nearest hundred. So this is basically a question asking us to round this number that we've been given to the nearest hundred. So if we have a look at the number, we have the units column here, we have an 8 in the units column, a 3 in the tens column, a 5 in the hundreds column, and then a 2 in the thousands column. So if we want to round it to the nearest hundred, we're either going to round down to 2,500 or round up to 2,600. And in order to determine if we're rounding up or down, we need to look to the number in the tens column, so this 3 here. And the 3 in this instance is less than 5, which means we're going to be rounding down. If the 3 was greater than or equal to 5, we'd be rounding up to 2,600, but because 3 is less than 5 and 3 is in the tens column, which is before the hundreds column, we're going to round down. So 2,538 is going to round to 2,500 to the nearest hundred. So in this question, we're given the first 4 terms of a sequence, which are 2, 9, 16 and 23. And we're asked to write down the next term in this sequence. So this question's 1 mark, it's just looking for us to write down the answer, so there's going to be a really simple and easy to spot relationship between these numbers. So a good place to start is always going to be looking at the difference between the numbers. So when we go from 2 to 9, we're adding on 7. And then similarly, from 9 to 16, we're also adding on 7. And then from 16 to 23, this is also a difference of 7. So when we're looking for what the next term's going to be, we're simply going to add on 7 again, keep this common difference, and that's going to give us 23 plus 7, which is 30. So the next term in the sequence is going to be 30. We're then asked to explain how we got to our answer, and that's basically asking us what we did to look at these terms and come to the conclusion of what the relationship is and what the next term is going to be. So a simple answer for this one is that there's an increase of 7 each time. So increases by 7, or writing that each term is 7 greater than the previous term, or alternatively coming up with the formula for this sequence. So that would be 7n minus 5 if we find what the 0th term would be. So 2 minus 7 gives us minus 5, and we've got that difference of 7, so 7n minus 5. Writing any of these things down would gain us this mark here for the explanation. We're now asked to work out the 10th term of this sequence, and in order to do this we could simply add 7 until we reach the 10th term, so we'd add 6 more lots of 7 onto 23, or we could work out the formula for this sequence and then use that to work out the 10th term. So if I go about it that way, I'm going to use the dyno method. So the di part means the difference, then we write the n, and then we want the 0th term. So we're going to find the difference between the terms, then write down the n, and then we're going to add on the 0th term, which is the term before this 2 that we have here. So the difference we have is plus 7, so we know that the difference is 7. And then we need to add that n, so we have 7n, and then the 0th term is going to be 2 minus 7 in this case, because we're working the other way through the sequence, and that gives us minus 5. So 7n minus 5 is the formula for this sequence. And if we're looking for the 10th term, so when n equals 10, as n is the term number here, we're going to have 7 times 10, subtract 5, so 70 minus 5, and that gives us an answer of 65 for the 10th term of this sequence. So here I'm told that we have 4 digits, so we have 7, 3, 4 and 9, and I'm asked to use 3 of these digits to write down the largest possible 3-digit number. So if I'm working with a 3-digit number, I know that in effect I'm going to have an integer in the hundreds column, then the tens column, and then the units column. And if I want this to be the largest number possible, I'm going to have to try and find the arrangement of these digits that gives me this largest number. So if I were to start with the hundreds column here, now if I had a number in the 900s, that's going to be greater than every number in the 700s, 400s and 300s, because 900 is greater than all of these others. So I could take that 9 and put it here because I know that the 900s is going to give me the greatest number. Now moving on, the same sort of principles apply, and I can then take the largest number left out of these 3 numbers that I have left over, so the 7. So if I'm putting this into the tens column here, 70 is going to be greater than 30 and 40, so that leaves me with a 7 in the tens column. And then finally, out of the 3 and 4, 4 is going to be larger, so 974 is going to be greater than 973. So my final answer here is going to be 974. So here I'm told that I have 4 different digits, so this time I have 8, 2, 1 and 6. And I'm asked to put one of these digits into each box to give the smallest possible answer to the sum. And we're also told that we're only allowed to use each digit once. So kind of applying the same sort of principles that we did in the previous part of the question, in order to get the smallest possible sum, I need the smaller digits, the smaller integers in the tens column. So if I have 2 2-digit numbers, this is going to be the tens column here. So I need the smaller integers to be in these columns to give me the smallest sum. So if I have a look at my numbers, 1 and 2 here are going to be the smallest possible integers that we have to work with. So I could put 1 of each of them in the tens columns. And then I'm left with the 6 and 8 to put in the units. And if you notice, either way round I do this, if I do 16 plus 28 or 18 plus 26, I'm going to get the same result of 44. So if I put the 8 in here and the 6 in here, this is going to give me the smallest possible answer to the sum, because we've got the smallest integers, the smallest digits in the tens column, and then the leftover ones in the units column here. So here I'm asked to write down all of the factors of 30. And I'm just noting here that I'm asked to write them down, so there's not going to be any kind of calculation or too much working out involved. So when I'm asked to list factors, I often find it easy to write them out as factor pairs, so that I can check that I've got all of the possible pairs of factors of the number, in this case 30. So starting off, if I take 30, that's going to be 1 multiplied by 30, gives me 30. So 1 and 30 are both factors. Moving up, I can go to 2, and 30 is even, so it's divisible by 2. And that gives me 2 times 15 gives me 30. So 2 and 15 are factors. Similarly, I can do 3 times 10. Then when I get to 4, 30 isn't divisible by 4, so 4 is not a factor. However, moving on to 5, 5 multiplied by 6 gives me 30, so that is a factor. If I were to carry on here, I would then get 6 multiplied by 5. However, we've already got 5 multiplied by 6, so we already have the factors of 5 and 6, so I don't need to carry on, and I know that I've got all of the factor pairs. So to list out the factors, I can simply write these numbers down that I have obtained from writing out the factor pairs. And that will gain me both of the marks for this question. If I'd only managed to find 3 correct factors and didn't have any more than 1 incorrect answer, that would gain me the first mark, and then having all of them correct would give me the second one. So in this question, I'm told that David has twice as many cousins as Becky, and then told that Becky has twice as many cousins as Nishat, and I'm told that Nishat has 6 cousins. And we're asked to use this information to find out how many cousins David has. So making sure to fully read through and understand a question like this is really important, because now that I've read all of the information and understand what I need to calculate, I'm going to go about this question by working backwards through the information and calculating how many cousins David has. So here I see that Nishat has 6 cousins, and I'm also told that Becky has twice as many cousins as Nishat. I could then use this to calculate the number of cousins David has. So if I work out firstly the number of cousins Becky has, so Becky is equal to twice, so 2 times the number of cousins that Nishat has, and that is 6. So 2 times 6 gives us 12. So Becky has 12 cousins. I can then take this further. David has twice as many cousins as Becky. So if I want to work out the number of cousins that David has, I again multiply the number of cousins that Becky has, this time by 2. So 2 multiplied by 12, and that gives me 24. So David has 24 cousins. So for the first part of this question, I'm asked to find the value of this surd that we have here. So we have the square root of 1.44 multiplied by 3.61. And I'm just noticing here that both numbers are under the square root sign. So we're finding the square root of the whole thing that we have here. So we could just type this into our calculators in one go. So the square root, and then we're going to take the square root of the multiple of 1.44 and 3.61, making sure both are under the square root sign. Or just to double check that we make sure we know what we're doing here, we could take the 1.44 times by 3.61 first, and that will then give us an answer of 5.1984. And then we can take the square root of 5.1984, and that will give us the final answer of 2.28. And that's the same answer that we would have obtained by just putting the whole thing into our calculator. So for this part of the question, I'm asked to find the value of this expression that we have here. So it's similar to the previous part of the question, but this time we're just working with a different expression. So I'm going to use the same sort of skills that I used in the previous part of the question, and again I'm going to be working with what we call BIDMAS. So this is the order in which you can perform kind of the calculations within a larger calculation. So the B in BIDMAS stands for brackets, the I is for indices, the D is for divide, then multiply, add and subtract. So this is the order in which we do things in the calculation. So the B first here means that I'm going to work with the brackets first. So as I can see, I do have brackets, so I can simplify whatever's inside the brackets before squaring it here. So squaring, this is an indice, so this comes second. This comes after manipulating the brackets. So I can start off here by taking that 3.54 minus 0.96 within the brackets and simplifying that. And if I do that calculation, that gives me an answer of 2.58. And as that's what's inside the brackets, I can then square that. So square 2.58, and that gives me an answer of 6.6564. And now if I look back to the BIDMAS that we have here, the only thing that I have left in the calculation is this minus 4.096, and this is subtraction. There's no addition, multiplication or division happening here, as we've already simplified this term, so we simply need to subtract 4.096 from it. So I'll take the 6.6564, subtract 4.096, and that's going to give me the final correct answer here of 2.5604. And I would have gained the first mark in this calculation if, so one of the numbers that I've been using to calculate is shown. So if I'd have reached this value here, so simplifying the first term, or similarly, possibly if I had rounded my answer, if I'd given my answer as 2.56, I also would have got the first mark, but not the second. So in this question, we have part of a bus timetable between Bury and Manchester, and then we have the timetable below, and we're asked how many minutes should the 8:25 bus take to go from Bury to Manchester. Now with questions like these, when we're given a table, it's often a good idea to kind of start by making sense of it and see what it's showing us. So if I have a look, in the first column we have the place names, so going from Bury to Whitefield to Heaton Park, all the way to Manchester at the end, the final destination. And then we have lots of times in this part of the table. Now, if we know that the bus is going to be stopping at all of these places, we must know that we're going to be working down the columns in order to see what time the bus is going to stop at each stop. So each column represents a different bus. So, for example, this column here is the 8:25 bus from Bury. So we go, it stops at Bury at 8:25, and then the same bus will stop at Whitefield at 8:34, etc., until it stops at Manchester at 9:05. So in order to calculate how many minutes this 8:25 bus should take to go from Bury to Manchester, I need to work out the difference between the two times when it stops at Bury and Manchester. So if it stops at Bury at 8:25 and at Manchester at 9:05, I can find the difference between these two. So I know there's 60 minutes in an hour, so I can count up from 8:25 to 9, and that gives me 35 minutes, and then I have this extra 5 minutes as it's 9:05 to add on. So the 35 plus 5 gives me an answer of 40 minutes here for the time taken. So in this question, I'm told that Daniel goes from Whitefield to Manchester by bus. I'm told that it takes Daniel 17 minutes to get from his house to the bus stop in Whitefield, and it takes 15 minutes to get from the bus stop in Manchester to his work, so at the other end of his journey. We're told that Daniel has to get to work by 10 AM and that he leaves his house at 8:45, and we're asked to use all of this information to work out whether he does get to work by 10 AM, showing all of our working along the way. So we're given a lot of information in this question, and it's often a good idea to kind of look through and see what we're going to be needing to work with first. So here I think it's a good idea to kind of start from the beginning. We're given the time that he leaves his house and the time that it takes him to reach the bus stop in Whitefield. So it's going to be a good idea to kind of use this to work out what the earliest bus possible he can catch is. So here we're told he leaves his house at 8:45 AM. So if I take this 8:45, I need to add on basically the time that it takes for him to walk to the bus stop from his house, which I'm told here is 17 minutes. So in effect, if I add on kind of 17 minutes here, this is going to take me to the next hour. So if we add on 15, we're going to get to 9 o'clock, and then we need to add on that extra 2 to get to 17. So that gives us a time of 9:02 a.m. Now, if I have a look at the timetable that we have, we need to see what the next bus he can possibly catch is. And he's catching this bus from Whitefield. So if I look in the Whitefield row, 8:34 has already gone, so he won't be able to make that bus. And here we have the 9:04 bus, which is 2 minutes after 9:02, so he will be able to get on this bus. And this is the next earliest bus to Manchester. So all of the other buses are later, and then they will arrive later in Manchester. So this bus is going to be the one that he needs to catch. So he is then going to get on the 9:04 bus we've established, and we can see that this 9:04 bus is going to arrive in Manchester at 9:35. So we can also write this down. Now he's arrived in Manchester at 9:35, and all he has to do from here is then walk to his work. And again, looking through all of the information that we were given, we're told here that it takes him 15 minutes to get from the bus stop in Manchester to his work. So we can take the time that he arrives at the bus stop and then add on that 15 minutes. So we basically have 9:35, add on 15 minutes, and that's going to give us a time of 9:50. And 9:50 is before 10 a.m, which is when he needed to be at work by. So we can conclude that yes, he will get to work in time. Now, as for how the marks are awarded here, so we would get a mark for a correct process to kind of show the time of departure for his train. So something to do with working out the original time it takes him to get to the bus stop, so that he'll reach the bus stop at 9:02. Some kind of calculation within the first part of the question gains us a mark. And then a second mark is going to be for the process to use a bus time from Whitefield to Manchester with other times. So either doing this original 17 and then calculating the bus time and working out when he'll get to Manchester, or at the other end, adding on this 15 minutes to a time that the bus reaches Manchester. And then the final mark here is going to be for the conclusion. So we've concluded with yes, and that's supported by the correct figure of the time that he will get there, which is 9:50. So in this question, I'm told that Bronwyn works in a restaurant, and we're given a table which gives her rates of pay. So here we have the day, so we either have Monday to Friday or the weekend in this left-hand column that we have here, and then in the right-hand column we have the rate of pay for each of the time periods. So it's £8.40 per hour Monday to Friday, so the weekdays she gets £8.40 per hour, and then at the weekend it's £11.20 per hour. We're told that Bronwyn worked for a total of 20 hours last week, and that she worked 8 of these 20 hours at the weekend. We're asked to show that Bronwyn was paid less than £200 last week. So a good way of doing this is going to be by calculating how much she was paid last week. So we can work out how much in total she was paid by calculating how much she was paid on the weekend and then in the week time. So we're told that she worked 8 of these 20 hours at the weekend. So we can firstly work out how much she was paid by working at the weekend. So we can multiply 8 by the hourly rate for the weekend, which is £11.20. And that gives us an answer here of £89.60. And now we need to work out how much she was paid during the week. So if she worked 20 hours in total, and 8 of them were at the weekend, we know that 20 minus 8, so 12 hours must have been in the week time. So we can then take this 12, multiply it by the hourly rate for the week, which is £8.40. And that gives us an answer of £100.80. Now I can take these two totals, and if I want to work out her total pay for the last week, I can simply add them together. So £89.60 plus £100.80 gives me a total here of £190.40. And then I can write that £190.40 is less than £200, which is what the question wanted us to show all along. So as for how the marks are awarded here, we'd get the first mark for the method of starting to work out the earnings, so one of these calculations here. The second mark is for the complete method, so the working out the other earning as well. And we also need to sum them together to achieve this mark. And then the final mark is going to be for this correct answer here of £190.40. So we're showing that this is less than £200. We're showing that she's paid less than £200 in the week. So in this question, I'm told that last year the cost of a season ticket for a football club was £560. I'm then told that this year the cost of the season ticket has increased to £600. And I'm asked to write down the increase in the cost of a season ticket as a fraction of last year's cost. So I can see that I have the two costs here, and it was originally £560 and it's then gone up to £600. Now if I want to write the increase as a fraction of the original price, I need to work out what the increase is. So I can do that here. I can take the 600, subtract that £560, and that gets me an increase of £40. Now, in order to answer this question, I need to write this as a fraction of the original amount, and the original amount, or the amount last year, was £560. So I can take that £40 and write it over, so as a fraction of £560. Now this does simplify, however, to get the marks to this question, this is all I need to write in the answer box. So 40 over 560 is going to be the fraction of last year's cost. So basically the increase in cost as a fraction of the last year's cost. So the first mark is awarded for kind of just starting to work with the method here. So for possibly this calculation here would gain us the first mark, and then the second mark is just for the correct final answer or any equivalent fraction. So this would simplify to 1 over 14 or lots of other fractions. As long as it's equivalent, you'll gain the marks here. So in this question, I have a diagram which shows a scale drawing of a tennis court, and then I have it below. So it's just a simple rectangle that we have here. I'm told that the scale of the drawing is 1 to 200, and I'm asked to use this to work out the perimeter of the real tennis court, given my answer in metres. So here I can see that I'm working with a scale. I don't have any side lengths or any measurements like that. So initially here, I know that I'm going to need to measure the sides of this rectangle that we have here so that I can scale them up to find the actual length. So I would measure the width and the height of the rectangle with a ruler, so lining up my 0 point with 1 point here, measuring to this point here, and that should give me a width for the rectangle of about 11.5 centimetres, or just above or below. And then the height of the rectangle, by lining my 0 point up here and measuring to this point here, so measuring this line, will give me a height of about 5.8 centimetres. I can now use this and scale it up to work out what the width and height of the actual tennis court are going to be. So if the scale is 1 to 200, this means that I'm going to need to multiply both of my values by 200 to find the real values. So for example, 1 centimetre in the drawing is going to be 200 centimetres in real life. So if I do the width first, I can take 11.5 and multiply that by 200, and that gives me an answer of 2,300, remembering this is in centimetres still. And then similarly, 5.8 for the height multiplied by 200 gives me an answer of 1,160, again in centimetres. So these are the widths. This is the width and height of the actual tennis court in centimetres. Now if I want to work out its perimeter, I'm going to need to sum all sides of the rectangle. So it's basically 2 lots of its height plus 2 lots of its width. So I could write this out as 2,300 plus 2,300, or 2,300 multiplied by 2, add on 1,160, add 1,160 again, to find the total perimeter of the real tennis court. And that then gives me an answer of 6,920, remembering that this is still in centimetres. So I now have the perimeter of the actual tennis court, the real tennis court. However, I've not quite finished, as the question asked me to give my answer in metres here. So I'm going to need to convert this centimetres into metres. Now if I'm going from centimetres into metres, so going this way, we need to divide our value by 100. If we were going from metres to centimetres, we would multiply by 100, but that's not necessary for this calculation. So I can take 6,920, divide that by 100, and that's going to give me an answer of 69.2 metres for the perimeter of the real tennis court. So now as for how each of the marks are awarded here, we would get the first mark for doing a correct measurement of the length or width of the tennis court. So this can be anywhere in a range of a couple of millimetres either side of both of the values. The second mark here is going to be for a process to find the actual dimensions. So for one of these calculations here, multiplying it up by 200, either the length or the width. And then the third mark is going to be for a process to convert into metres. So we did that at the end here. You could have done it while we had our original measurements, but I've just saved one calculation as I didn't have to do this for both of the individual width and length. And then there's going to be another mark for finding the perimeter. So that's what we did here, finding the perimeter of the total shape. And then the final mark is going to be for an answer. Our answer was 69.2 metres. However, any answer in the range of 67.6 to 70.8, this is just allowing for the variation in measurements at the start, is going to get you that final mark there. So that's how the 5 marks for this question were all awarded. They were quite easy to pick up as long as you worked through the question systematically and remembered to convert back into metres at the end. So in this question, we're given 6 straight line graphs and we're asked to match each equation in the table to the correct graph. And we're asked to write the letter of the graph in the table. So we have the table over here. So in this column we have the equations and we need to write the letters of the graph in the corresponding box. So firstly, if I start off with the graph of y is equal to 2. So this is going to be a straight line graph and it's going to be a graph that all of the points on the line have a y coordinate of 2. So if I have a look at the graphs, we need a graph in which every point on the line has a y coordinate of 2. So it's going to pass through the point 0, 2. It's going to pass through the point 1, 2. No matter what the x coordinate is, the y coordinate will be 2. And this is true for this graph that we have here, graph D. The y coordinate of the graph is always at 2, so this is going to be the graph of y is equal to 2. So that gives me D here. We then have y is equal to x as the next graph that we're working with. So this basically means that whatever the value of y is, x has to be the same value. So if y is 0, x is 0. So we know the graph goes through the origin. If y is 1, x is 1. If y is minus 2, x is minus 2. And that means we're going to get basically a diagonal line through the origin. And we've got 2 examples here. We've got this one here, graph C, and then graph F. And we can see that this line in graph F, it is true that the x and y values are always going to be equal. So for example, when x is 2, y is also 2 for this point on the line. However, for graph C, when x is minus 2, y is positive 2. So this is not the same. So y is equal to x is going to be the graph F here. And then finally here we have the graph of x plus y is equal to 2. Now this looks a bit different to the kinds of graphs that we're usually working with. However, it's easy to kind of manipulate to understand. So we're often used to working with graphs in the form of y is equal to something. So we can just rearrange this. So x plus y is equal to 2. If we subtract x from both sides, we end up with y is equal to 2 minus x, or minus x plus 2. So this is going to be a graph, if we look at this, the coefficient of the x term has a gradient of -1 and a y-intercept here, a plus c of 2. So a graph that has a y-intercept of 2 and a gradient of -1. So this graph has a y-intercept of 2 here, however its gradient is +1, it's increasing, and this graph here has a y-intercept of 2 and the graph is decreasing, so it has a gradient of -1. So this is going to be the correct answer here, so graph A is going to be the correct graph here. So this question's worth 2 marks. We'd get the first mark for getting 2 of these graphs correct, and then the second mark for getting all 3 graphs correct here. So in this question, we're given the marks for 20 students, what they got in a French test, and then we're given them below. So we can see they kind of range from somewhere in the 60s to somewhere in the 90s. Now we're then asked to use this data to show this information in a stem and leaf diagram. So for a stem and leaf diagram, we kind of have basically 2 main parts. We have one column which is going to represent the stem, which in this case is going to be the tens column, and then we have another column which is going to represent the leaves. So if I take this column here, it's going to be the tens column, so the stem, and then the leaves are going in this sort of area here. And how this works is we would take a number, so for example 76, the 7 is in the tens column, so there'll be a 7 in this column, and then in the corresponding row we will write the 6, which is the leaf. Now I can just write out a kind of key for this sort of idea. So if I were to do 7, 9, 6, for example, that is going to equal 76, and that's kind of a key for what we're doing here. Now I'm going to start off by doing an unordered stem and leaf diagram because it just makes it easier to begin with, as we need to look through all of the data and write them all into the table. So if I have a look at the tens, I can see the range from 60s to the 70s to the 80s and to the 90s here. So in the tens column, I'm going to write 6, 7, 8 and 9. Now I can go through all of the numbers individually and look at the units. So we have 76 here, so next to the 7 I can write the 6 in. Similarly for 82, next to the 8 I'll write the 2 in. And then I can just carry on through them, so we have 84 and I'll write the 4 in here next to it. Not worrying about the order yet, I'm going to continue and change the order at the end in the final answer. So I've done 84 and then I can just run through and do the rest, so 69, 80, 64, 70, 81, 75, 91, 87, 67, 80, 70, 94, 76, 81, 69, 71 and 77. And doing it this way and not ordering it to begin with just makes sure that I haven't missed any out and I've got all 20. I can count them all and check that I've got 20 leaves and just double check that I have got all of my points in here. So now I can go on to order them in the final answer for the stem and leaf diagram. So in the kind of answer box we have here, I'll write out the 6, 7, 8 and 9, and then I just need to order these numbers that I have here. So in increasing order, 4, 7, 9, 9, And then for the 7s, 0, 0, 1, 5, 6, 6, 7. For the 8s, 0, 0, 1, 1, 2, 4, 7. And then for the 9s, it's just 1, 4 again. Now, as for how the marks are awarded here, you'd get the first mark for kind of stating this key over here, so as an independent mark, so for just showing that this is how the stem and leaf diagram works. And then the second mark's for a fully correct, unordered or ordered stem and leaf diagram with one error or no errors. And then the final mark is going to be for this correct, ordered stem and leaf diagram here. So now we're told that one of the students is going to be chosen at random. We're told that the pass mark in the French test is 71. We're then told that Omar writes that the probability that this student failed the French test is 1/4. We're told that Omar is wrong and asked to explain why. So to go about this question, I'm going to try and find the probability that the student failed and compare this to 1/4 and show that it isn't 1/4. So if the student gets a mark less than 71, it's going to be a fail. So any mark up to 70 is going to be a fail. And I can use my stem and leaf diagram to find these values really easily and see how many scores were less than 70. So if I have a look at my diagram, if I want to go up to 70, I'm looking in this row here, so the 7, and we have two results which are 70. We then have 71, 75, and these are all passes. So the results that we are looking at are here, the two 70s, and then also all of the results in the 60s. So we can count these up. 1, 2, 3, 4, 5, 6 results, which are less than 71. So 6 out of the 20 students failed. So if I write down that 6 students failed this French test, I can then use this information to show that 6 out of 20 students failed, so that probability of the student having failed when one's selected at random is 6 out of 20. And if I simplify this down, this is not going to be equivalent to 1/4. So 6/20 is not equal to 1/4. And comparing these two values is what's going to gain me the mark here. So I'd gain the first mark for identifying that 6 of the students have failed, and then I'd gain the second mark for comparing this with 1/4 and showing that they're not equal. So we know that Omar is wrong and the probability is not 1/4. So in this question, we're told that Jenny is asked to find the value of this expression that we have here, so 12 minus 2 multiplied by 4. We're given her working, so she does 12 minus 2 multiplied by 4 is equal to 10 times 4, which is equal to 40. We're told that Jenny's answer is wrong, and we're asked to explain what she has done wrong. So we are looking at this calculation and looking at the order of operations that we have here. And there's a really useful sort of acronym that I like to use. It's BIDMAS. So this stands for brackets, indices, division, multiplication, addition, and subtraction. And this is the order in which you need to do the operations. So we have subtraction and multiplication here in this expression. And if we have a look down the list, multiplication comes before subtraction. So we need to do the multiplication before we can do this subtraction. So in effect, I can draw some brackets in around the multiplication. So we do that first. So we do 12 minus 2 multiplied by 4, which is 8. So 12 minus 8, so the answer should give us 4. So if we were to write 12 minus 8, that would give us the mark. Or we could simply write that she should multiply first. And we figured that out using this sort of BIDMAS method. So now we're told that Rayhan is asked to find the range of the numbers 3, 1, 8, 7 and 5, and we're shown his working, so it's 5 minus 3 is equal to 2. We're told that this is wrong and asked to explain why. So here it's important that we know the definition of a range, and the range is the difference between the greatest and the smallest values. So we need to find the greatest and smallest values in this list and find the difference between them. However, this is not what he has done in the question. He's done the difference between the last and first numbers, which aren't necessarily the biggest and smallest because this list is not in order. So the largest number that we have here is actually 8, and the smallest is 1. So those are the numbers we are supposed to find the difference between. So in order to gain the mark here, we simply need to state that the range of a kind of set of values is the difference. So the greater one subtract the smaller one between the greatest number in the set and least values. And that's not what he has done in this case. So here we're told that Alan, Bisper and Chan share a sum of money. We're told that Alan gets 1/8 of the money and Bisper gets half of the money. Chan gets the rest of the money. We're then told that Alan gets £2.50 and we're asked to work out how much money Bisper gets. So at the start of the question, we're told that Alan gets 1/8 of the total shares of the money, and we're also told that Alan gets £2.50. So we know that 1/8 of the total must be equal to £2.50. So if I were to model the total as some variable called t, I could say 1/8 multiplied by t, so 1/8 t, 1/8 of the total is going to be equal to this £2.50, which is what Alan gets. Now, in order to work out how much money Bisper gets half of the money. So if I were to find the total, I could then divide it by 2 to find half and to find their share of the money. So if I take this expression that I have here, I can find the total, so little t, by multiplying both sides by 8. So 1/8 t multiplied by 8 just gives me t, and that's going to be equal to 8 times £2.50. So the total is going to be £20. Now Bisper gets half of the money, so I need to find half of the total. So 20 divided by 2 is equal to 10. So the amount of money that Bisper gets is going to be £10 here. And as for how the marks are awarded, you get the first mark for starting out on the method, so for doing this 8 multiplied by 2.5 here, some sort of calculation with this, and then the second mark is for the correct final answer of £10. And now in this part of the question, we're asked to find the ratio between the amount of money that Alan gets to the amount of money that Chan gets. We're asked to give our answer in the form A to B, where A and B are whole numbers. So in the previous part of the question, we're told that Alan gets £2.50. We also worked out that Bisper got £10, and we also calculated that the total money was £20. We're told that Chan gets the rest of the money after Bisper and Alan have their shares, so we can work out how much Chan gets. So Chan is going to get the remainder, so we can take 20 and subtract both the amount that Alan and Bisper got. So we can take 20, subtract £10 and subtract that £2.50, and that gives us an answer of Chan having £7.50. Now if we want to work out the ratio of Alan to Chan, the amount of money that each of those got, we can write this out. So we know that Alan got £2.50, so A, and then Chan got £7.50. So this is the ratio of the two. However, we need this answer to be in whole number form. So the way that we can do that is we can divide both sides of the ratio by a common factor here, and probably noticed in this case that both sides are divisible by 2.5. So if we divide both sides of the ratio by 2.5, this leaves us with 1 to 7.5 divided by 2.5 gives us 3. So the ratio here is 1 to 3, where A and B are whole numbers. We need to make sure we do get them the right way around, so it's the ratio of Alan to Chan, not the other way around. But as for how the marks are awarded here, you would get the first mark for a process to find out chance share, so this 20 minus these values. And then a second mark is going to be for a correct ratio, so this ratio here, not necessarily in its simplified form. And then the final mark is for the final correct ratio in whole number form here, or it could be similarly a multiple of it, so 5 to 15 or something like that, as long as there are whole numbers. So in this question we have ABC, which is an isosceles right-angled triangle, and then we have the diagram below. So we have AB, which is equal to BC, which makes the triangle isosceles, and they're both 3x centimetres long. And then we have the right angle here between those two sides. We're told that the area of this triangle is 162 centimetres squared, and we're asked to work out the value of x. So initially here, we are given the area and we're given the side length of this triangle. So we're going to want to relate these somehow so that we can solve this for x. This is actually kind of an algebraic question in disguise, just using a triangle to set up the initial equation. So to find the area of this triangle, well, as we have a right angle here, if we were to extend some sides down here, we could create a square. So if I were to kind of draw those in just to see what it would look like, we would kind of have a square here with a right angle over here. And the triangle ABC is going to have half of the area of this square. So if we were to find the area of the triangle, we can do the base times the height and then divide this by 2. However, we have the base and height are going to be the same. So we have 3x multiplied by 3x multiplied by a half gives us the area of the triangle. 3x multiplied by 3x would just give us the area of this whole square. However, we just want this half of it, so just the triangle. And as that gives us the area of the triangle, we can make this equal to the area that we're given in the question, which is 162 centimetres, so 162. We can then do some multiplication here. We can multiply the left-hand side together. So 3x multiplied by 3x gives us 9x squared. And then multiplying that by a half, so we have 9 over 2 x squared. So 9 multiplied by a half. And that's still equal to 162. If we then go on, we want to solve for x. So if we divide both sides by 9 over 2, x squared is 162 divided by 9 over 2, and that gives us an answer of x squared being equal to 36. So x is going to be equal to the square root of 36. We know x must be positive because it's a side length. 3x is a side length, so x needs to be positive. We can't have negative side lengths. So x is going to be equal to positive 6 in this instance. Now, as for how the marks are awarded here, you get the first mark for using a process to set up an equation in x, so this line here would give us a mark. You'd then get a second mark for a process to simplify to x squared, so getting x squared to be equal to 162 divided by 9 over 2, or x squared is equal to 36. And then the final mark is for the correct answer here of positive 6. So in this question, we're asked to work out the value of this expression that we have here, so 2.645 times 10 to the power of 9, all over 1.15 times 10 to the power of 3. And we're asked to give our answer in standard form. So the numerator and denominator of the fraction are already in standard form, so it's going to be easy to kind of work with these and come to our final answer. So we could type this whole thing into our calculators, however it's always a good idea to kind of work through it logically and just check we know what we're doing with each part and make sure we don't make any mistakes, just to double check the answer that our calculator gives us. So working with two things multiplied together on the numerator and denominator, we can kind of work with these separately. So I can kind of isolate the first and second parts, the standard form parts and the kind of just number parts that we have at the start. So I can do these calculations separately and then it will leave me with an answer in standard form. So if I start by doing 2.645 divided by 1.15, that's going to give me an answer of 2.3, which is a nice answer. It only has a number in the units column, it doesn't have any tens, so we don't need to change this into standard form. And then similarly here, we can do the same thing with the 10 to the power ofs. And working with indice laws, if we have 10 to the power of A over 10 to the power of B, that simply gives us an answer of 10 to the power of A minus B. So that's one of the indice laws that we work with. So 10 to the power of 9 divided by 10 to the power of 3 gives us an answer of 10 to the power of 9 minus 3, so 10 to the power of 6. And then we can simply multiply the 2.3 and the 10 to the power of 6 together in order to work out this final value. So that leaves us with 2.3 multiplied by 10 to the power of 6, which is the final answer in standard form for this question. So in this question here, we have a scatter diagram which shows information about 12 girls. It shows the age of the girl and the best time she takes to run 100 meters. And then below we have the scatter diagram. So we have age in years on the x-axis and then time in seconds on the y-axis. Now for the first part of this question, we're asked to write down the type of correlation. So correlation between two variables basically is a way of showing how the two are related. So how time in seconds relates to age in years. And as we can see here, as the age is increasing, as the x values are increasing, the time in seconds is going to be decreasing. We can see this negative gradient here. If we were to draw in a line of best fit somewhere down here, there'd be a negative, it would have a negative gradient. So here we're going to have a negative correlation. So as one of the variables increases, the other decreases. Now in the second part of the question, we're told that Christina is 11 years old and that her best time to run 100 meters is 12 seconds. We're told that the point representing this information would be an outlier on the scatter diagram, and we're asked to explain why this is the case. Now, the kind of definition of an outlier is we're looking for something that doesn't fit this this trend that we have here, doesn't fit this negative correlation that we've already seen, and doesn't kind of fit in with the other points and the correlation of the graph. So if I have a look of where this point is going to be, if she's 11 years old, we're going to be at this point on the x-axis, and she runs it in 12 seconds. So the point is going to be drawn in here. And as we can see, if we were to draw a line of best fit over here, showing this negative correlation, this point lies nowhere near the line of best fit and doesn't continue the trend. So to explain why this point would be an outlier, we simply need to write something along those lines, so it's not in line with the trend of the other points, or that it doesn't fit the correlation that we've already spoken about in the first part of the question. We would also get the mark for saying it's far away from the other points or far away from the line of best fit. So now in the final part of the question, we're told that Debbie is 15 years old, and that Debbie says the scatter diagram shows I should take less than 12 seconds to run 100 meters, and we're asked to comment here on what she said. So if I have a look at the age of 15 years old, and go up to about where we'd expect the kind of general trend to carry on to, it would be something somewhere here around sort of the 12 second mark. However, as the points finish here, so the oldest person is somewhere between 13 and 14 here at this point, this is what is known as extrapolation. So we're extrapolating the data and going beyond the points which are shown on the graph. So this can't be said that the results are reliable beyond this point. So the point at which somebody is 15 is going to be outside of the range of the scatter diagram. So we can't really use it to predict how long it should take a 15-year-old, we can't be sure that this trend is going to carry on in the same way that it already has been. So I'm just going to say here that the point would be outside of the original range of the scatter diagram that we have above. And this means that we just can't reliably extrapolate or extend this data to come up with a time that it should take somebody who's 15 years old to complete the 100-meter race. So in this question, I'm asked to expand and simplify this expression that we have here. So 5 lots of p plus 3 minus 2 lots of 1 minus 2p. So I'm going to need to expand out the bracket so that I can simplify my terms, group some terms together and come to a final answer here. So if I take this first bracket first, I need to multiply p plus 3, the bracket, by 5. And I can do that by taking 5 and multiplying it by p and then 3 separately. So 5 multiplied by p plus 5 multiplied by 3. So I can do 5 multiplied by p gives me 5p plus 5 multiplied by 3 gives me 15. I'm just going to put that in brackets because that represents what I've just done there with the first bracket. And now similarly here, I have this bracket that I need to work with. However, this time we're subtracting. We have in effect a minus 2 here, which we need to multiply the terms in the bracket by. So if I take minus 2 multiplied by 1, and then I need to add on minus 2 multiplied by minus 2p. So I can add on minus 2 multiplied by 1, which is minus 2, and then minus 2 multiplied by minus 2p gives me positive 4p. So then I can add these two brackets together, collect the p's together and collect the numerical values together. So for the p's, we have 5p plus 4p. And to that we need to add on 15 minus 2. So it leaves us with 9p plus 13. And these values don't share any factors. 13 is prime, so we know we've got it in its most simplified form. We can't factorise anything out, so that's going to be the final correct answer of 9p plus 13 there to gain us the second mark. The first mark was just for starting to expand one of the brackets at the start of the question. So in this question, I have a trapezium drawn on a centimetre grid below, and I'm asked to, on the grid, draw a triangle equal in area to this trapezium. So we need to find the area of this trapezium and then draw a triangle of this area below it on the grid. So a good place to start here is going to be by finding the area of this trapezium. And the formula for the area of a trapezium is going to be half of the sum of the parallel sides times the height between them. That's a common rhyme that's often used to remember the area of a trapezium. So the formula here is half a plus b multiplied by h, where a and b are the parallel sides. So we have a and b here, which can be labelled either way round, and a has a length of 2, and b, if we count the squares, 2, 4, 6, 7 squares. And we're working on a centimetre grid, so we can just count the squares like this. We then need to find the height between the two sides, between the two parallel sides, and we can just find the difference between these two by looking at the vertical distance here, which is going to be 4 squares. So the vertical height, so the height of the trapezium is 4. So we can work out the area by subbing these into the formula. So a half multiplied by 2 plus 7 multiplied by 4. And that gives us an answer of a half multiplied by 9 multiplied by 4, which is 18. So we're going to need a triangle of area 18 centimetres or squares on the grid. And if we know the formula for the area of a triangle, it's just going to be a half multiplied by the base multiplied by the height. And we know that the area has to be equal to 18. We can multiply both sides by 2. So we know that the base times the height is equal to 36. And then we can basically find any two factors of 36, a factor pair of 36, so two numbers that multiply to 36, one of which will be the base of the triangle and one of which can be the height of the triangle. So simply here, I'm just going to take 6 and 6. So if the base is 6 and the height is 6, they multiply together to get 36. You could do 9 and 4. And then I'm just going to draw out a triangle of height 6. So it needs to have a height of 6 here. And then it needs to have a base length of 6 also. And then I can just connect these lines here. And I now have a triangle of area 18 centimetres, which is going to be the same as the trapezium. The first mark's awarded for finding the area of the trapezium, and then the second is for a correctly drawn triangle. So in this question, we're told that when a biased six-sided dice is thrown once, the probability that it will land on 4 is 0.65, and we're told that this dice is thrown twice. Amir draws this probability tree diagram, and the diagram is not correct. So if I have a look at the diagram, we can see that on the first throw, the probability it lands on a 4 and doesn't land on a 4, and then similarly on the second throw, having landed on a 4, it either then lands on a 4 again or doesn't land on a 4. And with this information in this tree diagram, we're asked to write down two things that are wrong with the probability tree diagram. So, especially when it comes to tree diagrams, I feel like a good place to start is going to be looking at what the probabilities sum to. So in each branch, in each kind of section of the tree diagram, on each throw, the probability of it landing on a 4 and not landing on a 4 need to sum to 1, as these are the only two outcomes that can happen. The probability of the sum of their probabilities must be 1, as these are the only two things that can happen. So if I have a look at the first branch, we have 0.65, which, yes, it says in the question, is the probability it lands on a 4. However, here we have 0.25 that it doesn't land on a 4. Add these together, and we're not going to get a total of 1. We're going to get 0.9. So that's the first thing that is wrong with this diagram. And if I carry on having a look, if we then go over to the other branches, I can see that the probability of it landing on a 4 again should be 0.65, because this is a new throw of the dice. There is a 0.65 probability that it does land on a 4. However, here we have a probability of 0.35 and the 0.65 is here. So these two are swapped. These are the wrong way round. The probability that it lands on a 4, despite it being the second throw, is still the same, and this one should be 0.65. So I can then just kind of put these ideas together and write up my answer. I've now found two things that are wrong with the tree diagram. And in the first box, I'm simply going to put the probabilities should always sum to 1. So 0.25 should be 0.35, and it's always a good idea just to kind of give an example of what you mean here. And then secondly, that for the second throw, the probability that this dice lands on a 4 should be 0.65, not 0.35 that it says in the tree diagram above. So that's for basically saying that the 0.35 and 0.65 are reversed. We get a mark for each of these ideas for getting a correct answer for each of the two things that are wrong with the diagram. Each one gives us a mark here. So in this question, I have ABC, which is a right-angled triangle, and then I'm given the diagram below, and I'm asked to work out the size of the angle ABC, giving my answer correct to 1 decimal place. Now, the angle ABC is going to be the angle between the sides AB and BC, so this angle that we have here is what we're looking to find. Now also I'm noticing here that I have 2 side lengths of the triangle, so I have this length here which is 7, and then as this is a right angle triangle, I have the length opposite the right angle, so I have the hypotenuse of the triangle here. Now I'm thinking that I've got 2 side lengths and I'm looking to find an angle, and also I have a right angled triangle. So what's kind of springing to mind here is the use of trigonometry. So if I were to label these sides up, kind of linking to this angle here, this side CB is going to be the side that's adjacent to this angle, as it isn't the hypotenuse, so this is going to be the adjacent. And then AB is the hypotenuse of the triangle, so I can label that as H. Now if I think of SOHCAHTOA, I have A and H, so K of the SOHCAHTOA, which means that I need to work with cos. So cos theta is equal to A over H, and this here is the angle theta that they're working with, and I can sub my values in. So cos theta is equal to the adjacent, which is 7 centimeters, over the hypotenuse, which is 11. So theta is the inverse cos of 7 over 11, and if we calculate that using our calculators, we get an answer of 50.4788 degrees. However, the question is asked for our answer to 1 decimal place, so I can round that to 50 point, and then here we have the 7, which means that the 4 is going to round up to 5 as 7 is greater than or equal to 5, so 50.5 is the final answer here. We'd get the first mark for kind of working with cos here, so the cos of theta is equal to 7 over 11, that gives us the first mark, and then the second marks for the correct final answer of 50.5 degrees. Now for the second part of the question, I'm told that the length of the side AB is reduced by 1 centimetre, the length of the side BC is still 7 centimetres, and the angle ABC is still 90 degrees. And we're asked whether the value of the cos of ABC will increase or decrease given a reason for our answer. So if I have a look at my triangle and label up the new side, so AB is the hypotenuse and that's been reduced by 1 centimetre, so 11 minus 1, this is now 10 centimetres. Now if I want to find cos of ABC again, I need to substitute that in, so cos of theta or cos of ABC is equal to the adjacent over the hypotenuse. Again, the adjacent is going to be the 7, and the hypotenuse has gone from 11 to now 10, so I now have 7 over 10. Now I need to determine whether this means it's increased or decreased. Before we had 7 over 11 for the value of cos of ABC, and if I have a look at these, we know that 7 over 10 is going to be greater than what we had before, which was 7 over 11. So therefore, cos of ABC has increased due to this change. So we just had to do kind of a small calculation here, comparing our result to what we had before to get the mark for this part of the question. So in this question, we're told that there are some counters in a bag and that the counters are red, white, blue or yellow. We're told that Bob is going to take a random counter from the bag, and we're given a table which shows each of the probabilities that the counter will be blue or yellow. So we have in the first row the colour, so red, white, blue or yellow, and the second row the probability of the counter being that colour. Red and white aren't filled in yet. Blue is 0.45 and yellow is 0.25. We're told that there are 18 blue counters in the bag, and that the probability that the counter Bob takes will be red is twice the probability that the counter will be white. And we're asked to use all of this information to work out the number of red counters in the bag. So initially here, if we want to find the number of red counters, we need to find the probability that the counter is going to be red in order to work with this and the total number of counters, which we can also calculate. So if I have a look at the information that we have, we're told that the probability the counter is red is twice the probability that the counter is white. So you could kind of fill this in. If the probability of a counter being white is x, the probability of it being red is 2x. Now, the counter that's picked has to be either red, white, blue or yellow, so all of their probabilities need to sum to 1 because they're the total, they're all of the things that can happen. Nothing else can happen if a counter's picked. So therefore, we know that 2x plus x plus 0.45 plus 0.25 is equal to 1. And if we add these x's together, we get 3x is equal to 1 minus 0.45 minus 0.25. And that gives us an answer of 0.3. So we now know that x is 0.3 divided by 3, so 0.1. And the probability of the counter being red is 2x, so 2x is equal to the probability of the counter being red is equal to 2 times 0.1, so 0.2. So we now have the probability that the counter is red. If there are 18 blue counters in the bag, we also have the probability that the counter is blue. So the probability that the counter is blue is 0.45, and that is equal to 18. So there are 18 blue counters. Now we can work out the total number of counters if we kind of take this as a fraction. So 0.45 lots of the total is equal to 18 counters. So if we let little t be the total number of counters in the bag, 0.45 multiplied by this gives us 18 counters, so those are 18 blue counters. So if we divide both sides by 0.45, we can take 18 divided by 0.45 to get us the total number of counters being equal to 40. And now if the probability of choosing a red counter is 0.2, we can simply multiply this by the total. So 0.2 multiplied by 40, as there's a 0.2, there's a probability of 0.2 of picking a red counter, and there are 40 counters to choose from. And 0.2 multiplied by 40 here gives us an answer of 8. So there are 8 red counters in the bag. Now, as for how each of the marks are awarded in this question, we would gain a first mark for finding the sum, for a process to find the sum of the unknown probabilities. So for finding the 0.3 here. The second mark is for finding the probability of the red counter or a white counter being chosen. So this 0.2 here we calculated. The third mark is for a complete sort of process calculation to find the number of red counters. So there's a multiplication by either finding the total or something similar here. And then the correct final answer of 8 gains us the fourth and final mark for this question. So now for the second part of the question here, we're told that a marble is going to be taken at random from a box of marbles. The probability that the marble will be silver is 0.5. And we're told that there must be an even number of marbles in the box and asked to explain why this must be the case. So the probability that this marble is silver is 0.5 or a half. So that basically means that half of the marbles are going to be silver marbles and half are not silver. And if half of the marbles are silver, half of the number of the total marbles needs to be a whole number, as we can't have half a marble. So this is where the even or odd comes into play. So if we're to half an odd number, it's never going to give us a whole number. So for half a number to be an integer, that number, the original number, must be even, and you can't have half a marble. So this means that there must be an even number of marbles in the box in order for this to work and for there to be able to be a probability of a half. So to get the mark here, I'm just simply going to write a half multiplied by an odd number will never be a whole number. And also, it's a good idea to add here, you cannot have half a marble. So you need a whole number of marbles in the box. You can't have half a marble, so you can't choose half of an odd set of numbers, as this will not give you a whole number, so this is not possible. So in this question, I'm simply asked to solve this expression, this equation that we have here. So I'm going to need to multiply out some terms and simplify it down in order to find the value of x that satisfies this equation. So when I'm working with something like this, I like to kind of see where it's easiest to start and what I can do in order to collect some terms together. So when I have a fraction, which I have over this side, I've got something divided by 2 here. Now it's going to make sense here if I start off by multiplying both sides by 2 in order to get rid of this kind of denominator that we have here. So if I multiply both sides by 2, I'm left with 5 minus x is equal to 2 lots of 2x minus 7. And I can then expand my brackets on the right hand side, so 5 minus x is equal to, and we can do this by multiplying the 2 by the 2x and the 2 by the minus 7. So 2 multiplied by 2x gives me 4x, and 2 multiplied by minus 7 is minus 14. Now this looks a lot easier and more friendly to work with in order to solve for x. So I kind of now want to get all of my x terms onto one side and all of my numerical values onto the other side so that I can calculate a value for x. So if I want to collect my x terms together, I have a negative x on this side, so if I were to add an x to this side, I would end up with just 5 left over. So I'm going to add on x to both sides of my expression, remembering that I have to do the same thing to both sides at all times, and that gives me 5 minus x plus x, so just 5 is equal to 4x minus 14 plus x, which gives me 5x minus 14. And now to take all of the numbers to one side and keep the x's on the other, I can add 14 to both sides, as I have this negative 14 here. So 5 plus 14 gives me 19 is equal to 5x. And then I just want to find the value of 1x, what one lot of x is worth, so I can then divide both sides by 5 to give me 19 over 5 is equal to 5x over 5, so just x. So the correct answer here is going to be that x is equal to 19 over 5, and that gains me that final mark here. So as for how the marks are awarded for this question, you're going to gain a mark for the first step, so kind of multiplying both sides by 2 gains us that mark here. There's going to then be a second mark for isolating terms in x, so getting all of the x's onto one side, taking them to the same sort of place here in this step, and then the final mark is for the correct final answer. So it can be simplified, it can be written as 3.8 or equivalent fractions. However, 19 over 5 will get us the mark here, along with anything sort of equivalent to it. So in this question, I'm told that ABCDE is a pentagon. We then have the diagram of the pentagon here. It's an irregular pentagon. We're told that angle BCD is equal to 2 times the angle ABC, and we're asked to work out the size of the angle BCD, showing all of our working. Now if I have a look at the diagram, we have a couple of angles already labelled up, so this angle here, and also this angle here is a right angle, so I'm just going to write on there that that's 90 degrees. I'm told here that angle BCD is equal to 2 times angle ABC. So if I were to kind of give these a name, I could label angle ABC up as X, for example, and then angle BCD is 2 lots of angle ABC, so this is going to be 2x. So then I can just label them up on the diagram. So if I look for BCD, this angle here is going to be 2x, and the angle ABC is going to be equal to x. So now I have all of the interior angles labelled up in my pentagon. Now, working with this, I need to kind of set up some form of an equation with the interior angles and their sum. So if I think back to possibly a formula that I could use, I could think about the sum of the interior angles of a pentagon. It doesn't have to be a regular pentagon to use this. And to find the interior angle sum, I'm just going to use the formula 180 lots of n minus 2. That gives me the sum of the interior angles, where n is the number of sides of the shape. So we have 180 lots of n minus 2, and n, this is a pentagon, so it has 5 sides minus 2. So 180 times 3 gives me 540 degrees for the sum of the interior angles. And then I can simply write this up into some kind of equation. So if I sum together all of the interior angles, so 115 plus 125 plus 90 plus 2x plus x, that's going to give me an answer of 540. Now if I add together my x terms on this side and then subtract all of my numerical values from the left hand side and the right hand side, we end up with 540 minus 115 minus 125 minus 90, and that gives us an answer of 210. And then I can find the size of angle x by dividing both sides of this by 3, and that gives me x as being 70 degrees. However, we've been asked to find the size of the angle BCD, so this angle here, which is 2x. So I need to take 2x, which is 70, multiplied by 2 to get 140, which is the correct final answer for the size of angle BCD. Now, as for how each of the marks are awarded here, you would get the first mark for the process to find the interior sum of the angles of a pentagon, so this kind of working out step here. The second mark is for the correct answer of 540. Similarly here, you could use the sum of the exterior angles and work that way round, but I feel like this way is just a bit more quicker and easier to get to the final answer. The third mark is for a process to start finding the angle ABC, so for summing together all of these and setting up the equation here. And then another mark is going to be for further process to find this angle, so for having this line here of 3x being equal to 210. And then the final mark is going to be for the final correct answer here of 140 degrees for this question. Now, as long as we kind of work through it step by step, logically, through the whole question, then we make sure to cover all of the points and we use all of the information in the question, then we'll make sure to pick up all of the marks here along the way. So in this question, I'm given triangle ABC and triangle DEF, which are similar. And I have the triangles below, and some of the side lengths are labelled up here. I can see that each of the kind of relating angles are the same, so all 3 angles in both triangles are the same, they've just been kind of scaled up by a different amount. I'm asked to work out the length of DF, which is this length here of the second triangle. So in order to kind of work with this, I need to understand the concept of similar shapes, and similar shapes are kind of basically when one shape has been uniformly scaled up to become a different shape, the same shape, just kind of a different size of it. All angles are preserved, it's just the side lengths which have changed. and these have changed by some sort of scale factor here. So if I can calculate this scale factor, I can work out the length of DF and how much greater it is than the kind of corresponding length of AC on the original shape. So if I have a look at my shapes, the length AB and DE are effectively in the same position relative to the angles that are the same, so we can work out the scale factor between these two. And I can work out that scale factor by taking the larger one, so the second one of 12.6 in this case, dividing that by 8.4, and that gives me an answer of 1.5. So 8.4 multiplied by 1.5 gives me this value of 12.6 centimetres for the length of DE. So similarly here, if I take the 6.4 and multiply that up by the scale factor of 1.5, I'm going to get the new length of this length here, DF, which is what I need to calculate. So I take 6.4, multiply that by 1.5, and that is going to give me an answer here of 9.6, just using that ratio. So the final answer here is 9.6 centimetres, and that's going to get me the second mark for this question. This first mark was for finding the correct ratio, so finding this as 1.5 if we're going from the first shape to the second. Alternatively, you could work back from the second to the first, and then you'd end up with a ratio of 0.66 recurring. But either way you do it, you'll come to the same conclusion of 9.6 centimetres for the length DF. So now for the second part of this question, we're asked to work out the length of CB, which is this length of the first shape this time. So last time, when we used our scale factor of 1.5 and multiplied it by the length on the first shape to get the length on the second shape, this time we're going to need to work with it slightly differently. So instead of multiplying by the scale factor, because we're going from the second shape, this length of 15 between these two angles, to this length here between the same two angles, we need to divide by the scale factor of 1.5 this time. So I can take this length of 15 and divide that by 1.5 in order to find the original length on the first shape. So instead of multiplying up by the scale factor, we're dividing by the same scale factor. And this gives me an answer of 10 centimetres, which is the correct length for CB. And we could check that if we were to multiply 10 up by the scale factor, we'd get 10 multiplied by 1.5. It does give us 15, so this does work in the other direction. So we'd gain the mark for getting the 10 centimetres correct, and for doing this calculation here using the scale factor, using that ratio from the previous part of the question. Now for this question, I'm asked to make G the subject of the formula, and I'm given this expression here with T on its own on this side and G here, which is underneath the square root. So the first thing I am noticing here is that this G is underneath the square root sign, and square roots are often problematic when I'm trying to isolate a variable, especially if it's underneath the square root. So a good place to start with rearranging this and trying to isolate G to make it the subject of the formula is going to be by squaring both sides of the bracket of the equal sign. So if I square the left-hand side, I'm simply going to be left with t squared. And then squaring the right-hand side basically cancels out the square root. So I'm just left with g plus 6 over 2. And this looks a lot more friendly, a lot more easier to manipulate when I'm trying to isolate g. So now what I'm noticing is that we obviously have this kind of fraction. We've got a denominator on the side that has the g. So in order to get rid of this, if I were to multiply both sides by a half, I'm going to have an expression on the right hand side which just has a single g term on its own, which I can then make the subject of the formula and is a lot more easy to isolate. So if I multiply both sides by 2, I'm left with 2t squared is equal to g plus 6, because the plus 2 and the multiplied by 2 and divide by 2 cancel out. And now it's really simple to make G the subject. I simply need to get rid of this plus 6 here. And I can do that, making sure I do the same thing to both sides of the equal sign by subtracting 6. So subtracting 6 from both sides of the equal sign gives me G. And that's 2t squared. Subtract 6. So the final answer for this question here is going to be that G is equal to 2t squared minus 6. And as for how each of the marks were awarded, the first mark is for squaring out the t, so giving t squared and squaring out the right hand side in order to kind of get that G in a form that's more easy to work with and manipulate. And then the next mark is for kind of going further with your calculation and multiplying both sides by 2 to get the 2t squared. And then finally for this final step of isolating G on its own. So as long as you kind of do the steps bit by bit, look for what you can do and what will help you try and make G the subject and get G on its own is really helpful in answering a question like this.